Hello and welcome back to Low Stress Math with Mrs. Bono. We are in Chapter 4, Functions, and we're on Lesson 5, Creating a Table of Values from a Function. And we're going to start with a word problem. It costs $2 per game to bowl at West Babylon Bowl, plus $3 to rent a pair of shoes. If the total spent bowling was $11, how many games did you bowl? And I gave you the let statement. Let x equal the number of games bowled. And now there's a problem. So pause the video and solve the problem. And when we get back, I'll go over it and welcome back. I hope you paused it because you know the only way to learn math is to do math. So let's do this problem together. You know, the first thing you have to do is rewrite this problem. 2x plus 3 equals 11. Okay. I'm going to subtract 3 from both sides of the equal sign and get, oops, my pen in the way. 2x equals 8. Divide by 2. And x equals 4. Well, that's great. X is 4. But what does that mean? It means I have to go back and reread the problem so I know what I'm supposed to write down. How many games did you bowl? Would 4 be an answer for that? I bowled 4 games. Yes, because x is the number of games. So I'm going to write that down. I bowled 4 games. Make sure that you're putting a unit on your work. Okay, but now there's more to it than that. That's if you only bowl 4 games or you know exactly how much money you have. What if you don't know how many games are going to be bowled? What if you're the owner of the bowling alley? Now you're going to want to know all of it. So let's come down here and organize ourselves a little table of values. Before I do this, I want to talk about what each one of these columns represents. This first column, the X column, that's the domain. And what's the domain? That's all the input values. That's what I'm going to put into my, and what this is, it's not an equation. There's no equal sign. It's just 2x plus 3. That's my function rule. So this is my rule. And the y is, I don't know. The y is the range. And that's the answer I'm going to get when I put my domain into the rule. I get the range. In other words, that's the output. And this right here, this is the coordinate. The coordinate. Coordinate pair. Sometimes I'll say the point. I use those interchangeably. So this is the point. You can graph the coordinate to get a point. And it's the domain x and the range y. Now, what am I putting in here? Well, up above, I said that x is the number of games bowled. So now I have to think about this using some logic. I'm going to pick my own domain. I'm going to know my own input. You could play 0 games. It could happen. You could be the mom going with your kids and, you know, being the driver, and they're the ones that are going to be bowling. But you go in with them anyhow because, you know, good parenting, you want to pay for their bowling. Or there's a lot of other reasons why you wouldn't be bowling. So I could have 0 games played. But I couldn't have negative games. You're not going to have negative games played. It's always going to be a positive number of games. So when you're doing a word problem and you're choosing your own domain, you have to think about it. You really have to use logic. I could go to a bowling alley and play 0 games, but I'm more likely to play 1 or 2 or 3 or 4 games. So what I'd like you to do when you choose your domain is think before you do it. Don't just pick random numbers. Choose numbers that make sense. Make sense in a word problem, make sense if you're, I don't want to use gigantic big numbers. I want to be able to do this relatively easy. Now, of course, I have Ty with me. Ty is going to help me do problems, but not easy problems like this. So let's do this problem. 2 times 0 plus 3. Well, 2 times 0 is 0, plus 3 is 3. What's that 3? I'm going to go back up and look at it. $2 per game to bowl plus $3 to rent shoes. Well, it makes sense that if I'm not playing a game, I still might have to pay that $3 to rent shoes. Why? Because they have very special floors in bowling alleys, and they don't want you to get dirt on their floors and scratch it up. And those floors are really slippery, so they want to make sure you have good shoes. So you're going to have to pay to rent shoes, even if you're not playing the game. So it makes sense that even though I'm playing 0 games, I'm paying $3 to do it. All right, the next one. 2 times 1 game plus that $3 to rent the shoes. Well, 2 times 1 is 2, plus 3 is 5. Interesting. Next one. Oh, wait, so that means if I play 1 game, I'm paying $5. Okay? Now I'm going to kind of cheat and write it out fast. So 2, 2, 2, because I'm always multiplying by 2. Now I'm going to put my domain in here. 2, 3, 4. Always in parentheses because a number next to a variable means that you're multiplying. So 2 times 2, 4, plus 3 is 7. 2 times 3 is 6, plus 3 is 9. 2 times 4 is 8, plus 3 is 11. So if I play 2 games, I'm paying $7. If I play 3 games, I'm paying $9. If I play 4 games, I'm paying $11. Do you see that there's a pattern? I went up by 1s with the x's, but I go up by 2s with the y. And I'm multiplying by 2. Look for these kind of patterns. These patterns actually will mean a lot in the future. So let me write down all my coordinates. 2, 7. 3 games, $9. 4 games, $11. And if I were to graph that, I wouldn't connect the points because I'm not going to play half a game. I only play full games. And if I play part of a game, they're going to charge me for a full game anyhow. Now, it says, is this relation a function? Let me see. Each domain has a unique range. Each x has a unique y. None of my x's are repeated. That means that it's a function. So is this relation a function? Yes, this relation is a function. And now I have to think of the because. This relation is a function because the domain does not repeat, the input does not repeat, the x values do not repeat. You put what you think when you read it. So I'm going to write the domain. I might even write the x's. I don't know. Yes, this relation is a function because the x values do not repeat. Haha, tricked you. And it's really important that they do not repeat when it is a function. I gave myself way too much room to write that. All right, next page. Come on, Bono, here we go. Oh, look at that. Now for me, this is easier. Why is that? Because they gave me the domain. So up here, that's my domain. So I know what to put in this first column. I'm going to put -2, -1, 0, 1, 2. And also, y equals 2x. Well, the function rule is 2x. And you know what? I'm even going to write above here, domain and rule. And I'm looking for the range and the coordinate. And what is the coordinate? The coordinate is the x and y values. Okay, so here it's going to be always times 2, because that's what the rule is, times 2. So 2 times -2. I don't know what I was going to write there. 2 times -1, 2 times 0, 2 times 1, and 2 times 2. Well, let's see. 2 times -2 is -4. 2 times -1 is -2. 2 times 0 is 0. 2 times 1 is 2. 2 times 2 is 4. Oh, I'm multiplying by 2 again, and look at this. -4 plus 2 is -2. -2 plus 2 is 0. 0 plus 2 is 2. And I'm going up by 2's. So whatever I'm multiplying by, that's the number that the y's will increase by. That's why it's good to have numbers that go in order so that you can see the patterns more clearly. And what are my points that I'm going to graph? Well, let's take a look at that. -2, -4, -1, -2, 0, 0, 1, 2, and 2, 4. And it's really important that the order, that you put them in order, that the x is the first coordinate and the y is the second coordinate. Because looking down at the graph, which is down here, x is right left, y is up down. So when I put my points on here, I'm looking to go right and left first, then up and down. And my first point is -2, -4, way down to there. -2, -4. My next point is -1, -2, right, left, then up, down. The next point is 0, 0. I'll put that there. The next point is 1, 2, over 1, up 2. And the next point is 2, 4, over 2, up 4. Okay. Is this a linear function? Well, how do I know if it's a linear function? Well, if I can connect these points, and I'm just going to kind of use the side of my calculator here because I didn't bring a ruler. If I can connect these points and it forms a line, which looking at this, it does. Yeah, I kind of messed up there a little bit, but all right. Is this a linear function? Well, yes. Yes, it is. Why? How do I know? Well, two things. I know it's a function because the x values don't repeat, and I know it's a linear function because it looks like a line. So, how do I know? It is a function because the x values do not repeat. and it's linear because it looks like a line. And I just spelled linear wrong. What is wrong with me today? Silly Bono. Linear starts with the word line. Look at that, L-I-N-E. And I was going to spell it without saying the word line, linear. And its graph is a line. So it is a function because the x values do not repeat and its graph is a line. Remember, the thing that you put on the grid is your graph. This line is the graph. These boxes and numbers in the background, that's the coordinate plane. The graph is the line, the background is the coordinate plane. Okay, and so many practice problems. How do you complete the table of values? How do I complete the table of values? Mostly I'm going to ask you to try these 4 problems, so pause the video and read the directions. Pick values for the domain, x coordinates, solve for the y coordinates, list the points of the ordered pairs, complete each table. There has to be at least one negative number. At least one negative. You could use 2, but at least one of them should be negative. Okay, pause the video and put some points in. All right, welcome back. I'm just going to use the same domain that I had over here. My x values were pretty easy, right? I'm just going to use those same x values for all of my points. So I had -2, -1, 0, 1, 2. And I'm going to use that for all of these graphs. Oh no, -2, -1, 1, 2. And that's going to be my domain for all 4 of them. Now, let's take a look. Here's my rule, x plus 4. So, no matter what x is, I'm just going to add 4 to it. And that's my rule. So, if x is -2, I'm going to add 4. If x is -1, I'm going to add 4. If x is 0, I'm going to add 4. If x is 1, I'm going to add 4. If x is 2, I'm going to add 4. So let's take a look at this. -2 plus 4 is just 2. -1 plus 4 is 3. 0 plus 4 is 4. Oh, look, I got a pattern. 2, 3, 4. 1 plus 4 is 5. 2 plus 4 is 6. Look, there's only one x here, and the numbers are going up by 1. Ha ha. That's how that works. Now I got to write down my coordinates. -2, +2. -1, +3. 0, 4, 1, 5, and 2, 6. Okay. My rule over here is going to be x minus 1. That means no matter what the x is, I'm going to subtract 1. So if x is -2, I subtract 1. If x is -1, subtract 1. 0, 1, 2. Let's do these problems. Keep, change, change. -2 plus -1 is -3. -1 plus -1 is -2. 0 plus -1, -1. Well, 1 minus 1 is 0. 2 minus 1 is 1. Okay. Not horrible. My x and my y. Oh, I forgot to write my x and y over here. Bad Bono. Here you go. -2, -3, -1, -2, 0, -1, 1, 0, and 2, 1. And you can see these are going down. Well, actually, no, they're going up. It's going up by 1. So as this increases by 1, this increases by 1 because there's only one x, so they're going up by 1. Haha. Before I do this, I'm looking at this problem here. 3x plus 8. This is 3 times x. I already know that my y values are going to go up by 3. How do I know that? Because I'm multiplying by 3. And that's how you do this. Let's try it. I'm always going to multiply by 3. 3 times everything here. Woo! 3 times -2, 3 times -1, 3 times 0, 3 times 1, and 3 times 2. Always multiplying by 3. Then I have to add 8 to all of these. Okay. 3 times -2 is -6, plus 8 is 2. 3 times -1 is -3, plus 8 is 5. 3 times 0 is 0, plus 8 is 8. And I'm right. See, it's going up by 3. 2 plus 3 is 5. 5 plus 3 is 8. When I multiply by 3, these go up by 3. 3 times 1 is 3, plus 8 is 11. 3 times 2 is 6, plus 8 is... wait a second. It's 14. I should have just added 3. All right, here are my x and y values. -2, 2. -1, 5. 0, 8. 1, 11. And 2, 14. Okay, over here. Oh, this is -1 times x plus 3. That means I'm multiplying everything here times -1. When there's a negative in front of the x, you're multiplying by -1. So -1 times -2, -1 times -1, -1 times 0, -1 times 1, and -1 times 2. And then add 3. So -x is the same as multiplying by -1. Negative times negative, +2, plus 3. Oh, come on, stay with your colors here, boy. Oh, wait, no, Bono. Did I just make a boo-boo? Yeah, 3 plus 2 is 5, not 4. What's wrong with me today? All right, negative times negative is +1. 1 plus 3, there's the 4. Negative times 0, 0 plus 3, 3. -1 times 1, -1 plus 3, 2. -1 times 2 is -2, plus 3 is 1. Look, they're going down by 1. That's because I multiplied by -1. All right. Now I just have to write down my x's and y's. -2, 5. -1, 4. 0, 3. 1, 2. And 2, 1. All right. I'd like you to try the problems on page 13. And I'm actually going to stop the video and make another video. I will talk to you soon. Have a great day. Bye.